This is the last section of the circles chapter, and this is to do with circles and triangles and links between the two. Now the first one, we all know about cyclic quadrilaterals. So basically a cyclic quadrilateral is where you draw a four-sided shape inside of a circle. Yeah, all four of the vertices are on the circumference of the circle. Well, if we do something similar with a triangle and we draw a triangle so that all three of its vertices lie on a circle, or another way of saying it is if you take a triangle and draw a circle that goes through all three vertices, that circle that you draw is called a circumcircle. Okay, so a circumcircle passes through the vertices of a triangle. All three vertices passes through, I should put all three vertices of a triangle. And what's interesting about that is that if you were to take each of the sides and bisect them like this, and I was to find the center of each line, and I was to draw a perpendicular bisector, so this is by eye here, not perfect. There's one perpendicular bisector. Here's another one here. So this is not going to be perfect by any means. And a third one here. Yeah. What is meant to happen when it's drawn better than my one is that all three of those bisectors pass through the center of the circle or the circumcircle. Okay, so the perpendicular bisectors of each side of the triangle. In fact, each side of the triangle forms a chord of the circle. The perpendicular bisectors of each side of the triangle, these chords of the circle, pass through the center of the circle, pass through the center of the circle. And in fact, you only need like two of them really to find the center. You don't find all three. But basically, the center of the circumcircle is the bisector of these three chords, and these three chords are actually the three sides of a triangle. Okay, here's another circle theorem from GCSE here, where you have a triangle on the diameter is always a right angle triangle. Yeah, so that should be familiar. That's not anything new. The one underneath it though is probably new. You may not have seen that one before. And what that is it's almost like the circumcircle thing. If I just got rid of one of the sides of the triangle, okay, so if I actually drew this line in, it's basically like the last one, yeah. But if we get rid of that and we've got these two chords, then the bisectors, the perpendicular bisectors of these two chords pass through the center. And in fact, the perpendicular bisector of any two chords of a circle will pass through the center of a circle. So we just write that the perpendicular bisectors of any two chords of a circle pass through the center of the circle. Right, we've got these 3 points, A, B and C, which lay on the circumference of a circle. So that tells us that this is a circumcircle. Circumcircle. And in part A, we need to show that AB is the diameter. In other words, we need to show that this line here is the diameter of the circle. Now, we're going to use the circle theorem, which says, right, if you've got a triangle on a diameter like this, then it's a right angle triangle, okay? So that means 2 things. That means that either Pythagoras will work on all 3 sides. So if you do the shorter sides, do Pythagoras on the shorter sides, you should get the diameter. Or we can prove that we've got a right angle at the top. And the way to prove we've got a right angle at the top is that the 2 chords should be perpendicular. The 2 chords are perpendicular. So let's go for the second one and prove that those 2 chords there, the chords AC and BC, are perpendicular, which means we must have a right angle, which means that that line I've highlighted in red must be the diameter. So the first thing, let's work out the gradient of AC. So gradient in AC is going to be the change in y, so 9 minus 1 over the change in x, which is going to be -4 minus -8. So that will give me 8 over -4 plus 8, which is going to be 4. So AC has a gradient of 2. Now let's have a look at the gradient of BC. The gradient of BC is going to be the change in y. So let's do, could do either way around really. Let's do 5 minus 9 over 4 minus -4. So that gives me 5 minus 9 is -4. And then I end up with 4 plus 4, which is 8. Okay, which is a -1/2. Okay, so since a gradient of AC equals -1 over the gradient of BC, therefore AC and BC are perpendicular, which means that angle ACB is a right angle, therefore AC is the diameter. Part B, find an equation in a circle, so we need to find its centre and its radius. So let's find the centre, that's going to be easier. So that's going to be the midpoint of AB. Okay, equals midpoint of AB. So that's going to be -8 plus 4 over 2 and 1 plus 5 over 2, and that will give us -8, so -4 divided by 2, which is -2, and 6 divided by 2, which is 3. So we have the center of the circle. Now we want to find the radius, which is going to be half the length of the diameter. So you can use Pythagoras to find out the length of the diameter. So we can write that as it's the length between A and B. So we can write those 2 bars to show that means the length of. So we're going to do Pythagoras on those measurements. Look at my square root sign going like this because I know it needs to be quite big. So that's going to be -8 minus 4, the difference between the x coordinates squared, and then the y coordinates, the difference between the y coordinates is going to be 1 minus 5 squared. So let's work that out. So that's going to be the square root of -12 squared plus the square root of -4 squared. So that'll be, oops, let's put the bracket in the right place. It's 160. So let's see if that simplifies. Square root 160 is 4 root 10. 4 root 10, which means the radius is half of that. So the radius is 2 root 10. So the equation of this circle is going to be x. Now remember, it needs to be minus. So x, sorry, not minus, but x minus -2. So it becomes x plus 2 squared plus y minus 3 squared. And it's going to be 2 root 10 squared. So let's work out what that is. And we get 40. So there's the full equation of our circle. Just highlight that there. Okay, so the first thing we probably want to do is to just sketch this out. So we got some sort of idea. So there's my circle, my terrible circle. I have 3 points, P, Q, and R. Yeah, it's just labeled like this. This is not to scale or anything like that. This is just to get my head around what we need to do. So these coordinates are 3, 16, 11, 12, and -7, 6. So there's my coordinates there. And we're told that the equation of the perpendicular bisector of PQ, so PQ is this line here, its perpendicular bisector, this line, like that. Oh, that's a bit off. Let's try and draw that a little bit better, and in a different colour. Let's draw it like this. This perpendicular bisector here, its equation is y equals 2x. And in part A, we need to find the equation of the perpendicular bisector of PR. So PR is this, and its perpendicular bisector, let's do it in a different colour here. So we want to find the equation of this line here. This is basically part A. So to do that, we need the gradient of PR. So gradient of PR, which is the change in y. So let's do 16 minus 6 over the change in x, which is 3 minus -7. Okay, so that gives us 10 over 10, which is 1, which is nice. So the gradient of this perpendicular bisector is going to be -1. So gradient of, I'll just put perp by, is -1. Now the next thing that we need is the midpoint of PR. So midpoint of PR. So to do that, we add the x coordinates together. So 3 minus 7, divide that by 2. We add the y coordinates together. which is 16 and 6. Divide that by 2. So what we're going to get is negative 4 divided by 2, which is negative 2. And then 22 divided by 2, which is 11. Now we can use y minus y1. So y minus y1 equals m, negative 1. X minus x1, so x minus negative 2. It doesn't say which form. Let's tidy up first of all. So y minus 11 equals negative x, and then we'll have negative 2. So let's write it as y equals mx plus c. So y equals negative x, then add 11 to both sides. So y equals negative x plus 9. So there's our answer for part A. Okay, part B says work out the centre of the circle. Now what's important about the centre is that's where these two perpendiculars bisectors cross. So we've got that on my diagram here. This is the centre. Yeah, so where these two perpendicular bisectors of the chords cross is the centre of the circle. So it's where the lines y equals 2x and y equals negative x plus 9 cross. So we want to solve those simultaneously. So let me just write down the centre is where y equals 2x and, or the lines y equals x and y equals negative x plus 9 intersect. I should say where the lines really, not just where intersect. So to find out where we intersect, we're going to solve them simultaneously. So we'll have 2x equals negative x plus 9. If we just substitute the y for 2x. So add x to both sides, we'll have 3x equals 9. That's nice and easy, which means that x equals 3. So that's the x coordinate where they cross. I was going to say quash. Then the y coordinate then will be 2 times that, 3, give me 6. So the centre of the circle is the coordinate 3, 6. 3, 6. That's part B done. And that's using the fact that these perpendicular bisectors of the chords cross in the centre. Now part C of this question, we now need to work out the equation of the circle. So we need two things. We need the centre, which we've already got already, 3, 6. We now need to find the radius. Now the radius is the distance from the centre to any point on the circumference. So we need to find either the distance from here to this point 316, or from that point to negative 7, 6, or from this point to 11 to 12. We can use any one of those points. Now I'm going to use the point P simply because I just feel like doing it. There's no other reason really, but you can choose any one. So what I'm doing now is I'm working out this distance here, and I know the coordinate of the centre, so that is 3, 6. So I'm basically finding the distance between the point 3, 6 and the point 3, 16. I'm finding the length of that. Okay, so I'll just write down radius equals distance from centre to P, and that's going to be the square root of, so I want the difference between the x coordinates. That's going to be 3 minus 3 squared. Now in a minute I'm going to show you there's probably a little way we can work that out much quicker without even doing Pythagoras, but let's do this first. Then the difference between the x coordinates squared. Okay, now basically what you end up with is the square root of 10 squared, so you end up with 10 as the radius. Now, was there a quicker way? Now let's have a look at these two coordinates again. Let's have a look at these two coordinates, 3, 6 and 3, 16. Right, 3, 6 to 3, 16. If I were to draw these out like this, you may have already worked out already. If I were to draw out what those two coordinates are, they're both above the point 3, and the center is 3, 6 here, and a point on the circumference is 3, 16 here. So our circle's going around something like this, yeah, with the center there. Well, the radius is just that length there. It's just 10. So even without doing Pythagoras, we could have worked out the radius of that circle. You could have used any of the points, and in fact, if you'd used point R, that would have been another way of working out the radius, because there you've got negative 6, oh sorry, negative 7, 6. So basically you've got another point on the circumference over here, yeah, and the radius would have been this distance here, and that is negative 7 down here, so that would be negative 7. Yeah, so again, you would get the radius here by doing 10, or you would got the radius going up as 10. So we could have done it actually without doing any Pythagoras at all. Right, anyway, now we can get the equation of the circle now that we have a point that it passes through and its radius, the center and its radius. So x minus 3 squared plus y minus 6 squared equals 10 squared, or 100. So there is our equation of the circle. Right, you should now be able to do exercise 6F on pages 131 to 132. So let's just run through quickly, quick recap. So if we have a triangle drawn on a diameter here, we have a right angle, these two sides are perpendicular, or you could say, well, if those two sides are perpendicular, then the other side is going to be the diameter, so perpendicular there, so that's where you can use that minus 1 over m there. And we have the diameter, that's just your GCSE circle theorem. If we have 3 points on the circumference, okay, that I'll call A, B and C, and those 3 sides form 3 sides of a triangle, then this thing here is called a circumcircle. Circumcircle. And if we were to work out or find the bisectors of each of those sides, like this, so all 3 of these sides get split in half, the bisectors cross at the center. Okay, so bisectors, or perpendicular bisectors, they're not just bisectors, are they? So perpendicular bisectors of sides, and each side of the triangle is basically a chord, isn't it, of the circle, go through the center. Now, because we only need basically 2 of those bisectors to find the center, okay, my circles are getting better here, then actually I just need 2 chords. So if I've got 2 chords like this, and let's call these points P, Q and R, so you could think of this as basically like 2 sides of the triangle, then these 2 bisectors, I can use these 2 bisectors, perpendicular bisectors, to find the center. Okay, so it's like the circumcircle thing, but with a side of the triangle missing. You don't need all three sides. So what we can say from this is that the perpendicular, I'll just put perp by, of any two chords, and they don't even have to be chords that are sort of touching like that, any two chords meet at the center of the circle. So those things are going to help you to answer problems to do with circles and triangles.